Hi, I'm Keith Blackstock. This is just going to be a short little video, probably the first of a short series of devlogs around this latest autonomous fixed-wing drone that I'm designing here. So yeah, I mean, as you can probably tell, if you can catch the layer lines with the light there, this is an entirely 3D printed airframe. And you can take note of the elliptical wing plan form. Took a lot of inspiration from classic planes, warbirds like the Spitfire, P-51 Mustang, P-39 Aero, A1 Mitsubishi Zero, that kind of stuff. Adapted it a little bit to accommodate some of the other design changes and equipment that I integrated here. So let me actually take you under the hood here. And right now I've just got a bit of tape there. Probably come to replace that with a hinge. So here, and it's encased, so you can't quite see it all the top of it, but this is a Maytech F411 WTE. It's one of Maytech's, one of the flight controllers in Maytech series. And these are nice because you can upload a number of different flight control firmware, such as ArduPilot, iNav, Betaflight, and a few others that I'm probably forgetting the name of up here. And you can also just write your own flight control firmware. But these are great. They've got here this is a very small one because this is a very small plane. I mean, you can kind of see my hand. For size comparison, it's a pretty small bird. But this gives me 4 UARTs for 4 hard UARTs and then 2 soft serial ports for a total of kind of 6 peripherals here. And that is plenty for the basic setup. So on the underside of the canopy here, I've got a very basic GPS. It's kind of like a cheap Chinese brand of GPS, but it does get a positional lock. If you bring it outside and initialize it, it's able to scan for satellite constellations pretty easily and give me a pretty reliable lock. This one doesn't have a magnetometer in it, but in the flight controller software, it actually does a clever thing where it looks at your instantaneous position and then calculates your heading angle based off of that. So that's really fun. Behind it, any of you familiar with just basic RC components, standard 6-channel PPM receiver here. Actually, it's more than just PPM because you also have iBus and SBus capabilities here, so that's cool if you want to like combine everything to one serial line. Tucked around in here, maybe I can pull it. Maybe or maybe not. But there's an ESC over here in the front end. Yeah, the camera angle there is a little bit difficult, but it's okay. We won't worry about it. Over here in the front, we have an Emax 2207. This is it's a pretty good, pretty light motor. I mean, I really like the form factor of these because these output a good amount of thrust for the size. Show you without tearing any of my wires out here. This might be part of the video that I edit for speed, but kind of gently, I know you're able to kind of see that there. It's really only the tip of it, but this is running a 2S battery. And I've got a little battery bay down here that I've designed for it. So that just tucked back there. And yeah, let's go to talk a little bit about the control scheme here. So if you've been observing the wings, you might note the lack of ailerons, which is, it's somewhat atypical for a lot of modern planes, because you want your direct roll control. But one of the neat things you can do if you have sufficient dihedral is fly what is like sometimes called a 3-channel setup. Sometimes called a bank and yank type setup, where you actually use the dihedral effect to induce a roll. So you can imagine if the plane is cruising forward, and then I use my 2 rudder vaders back here, more on those in a second, to turn, say my left. You can note here that there's going to be a higher angle of attack on the outboard wing, and then also while the rotation's happening, a slightly higher airspeed on that outboard wing, and that's going to generate more lift. So you can use this as a passive rolling, passive coordinated bank phenomenon if you have sufficient dihedral and everything's kind of trimmed properly. But more on the tailplane here. So gone for a V-tail, which is a little atypical on full-sized aircrafts. I think the only one that really comes to mind is like the Beechcraft Bonanza. That plane has a V-tail. But aside from that, you don't see these a whole lot in full-size aircraft, but you see them a lot in drones. And the reason here, you can see that right there, is you just eliminate a ton of drag. So like a lot of your airflow kind of come down the center line of the aircraft's body frame. So when you just delete that center fin, that center rudder, it removes a lot of drag. And also, you get these high efficiency rudder vaders where, they're set off at an angle of roughly 45 degrees. And then in coordinating their motion, you can produce a yaw, or you can produce a pitch by either moving them together in concert this way, or that way, or moving them up and down together respectively. So, and then in addition, you also save on weight, which is great. Not only because you have one less tail feather back here, but because you also have one less servo. I only have 2 servos in this entire thing, which really helps cut down on weight significantly. The weight, by the way, being around about 420 grams at this point, and they're just mounted on the underside here. The control wires are kind of tucked pretty nicely under the main tail here, and then they drive these little hinges right here, pretty traditional RC aircraft hinges, right, or control horns rather. These surfaces are created with a print-in-place hinge design, which is really good for just ease of manufacture and hinge reliability. So these are nice when just this entire thing just comes right off the print bed, and then you're ready to just insert it into the slot, and you're good to go. And then let's see, telemetry. Yeah, that's right. So you're really not going to get a very good camera angle of this, but there is, in addition to the receiver, which transmits on 2.4 gigahertz, you have a 900 megahertz long-range telemetry radio. So the receiver does send back telemetry, but only about battery life. So if you want to know things like the angle readings off of the IMU that's on board of the flight controller, or if you want to know velocity, or anything else that's being calculated on your FC, you hook up a telemetry radio, and then on there's like the air module, they call it, and then on the ground control station side, which is really just my laptop, I've got a similar module that receives that signal, and setting this up in iNav, it was pretty easy. Like as soon as I kind of hooked everything up and then got the radios synchronized, I was immediately getting attitudinal telemetry. I was just like doing this little number right here and seeing the IMU return the angle and orientation of the aircraft. So let's see, unless I'm forgetting anything, that should be just about it. This is an ongoing project, so I'm probably gonna release a subsequent set of videos. It's gonna go into each of these different aspects that I gave a really quick run over, just in a bit more detail, because everything from like the CAD design of the components to like all the lessons learned in flight tests. There's quite a bit here to dive into, but in the interest of time, I think I'll end it here. Take care.